Yesterday we talked about how exponentials are y equals a times b to the x. We talked about how a was a starting point, or the y-intercept, and that b was a common ratio, which you multiply by. But if you remember when we did our unit, it was a really short unit on exponentials, we also did some work with like percentages, and in these word problems, sometimes we had to add it to, or add 1 to it, or take it minus 1, or 1 minus the percent. So here's what it looks like on the EOC reference sheet, because you do have this on the EOC reference sheet. A equals P, and it's 1 plus or minus R over N to the NT. This looks extremely similar to the one that we used. We just got rid of the N, okay? So we didn't do the N because we did everything happening like on a yearly basis. So if it happens on a yearly basis, your N is 1. But if it happens more than once a year, then we'll change this N number. I think actually on your weekly reviews, you guys may have done some like this. So what these things are, okay, A would be obviously your ending amount. P is the starting amount, or the principal. R is your percent as a decimal. Remember this? N is the number of times it happens in a year. So if it's happening yearly, it's happening once per year. And then the T, so that goes for this N as well. Then it would happen, I guess, maybe 0.5. You won't hopefully see that. And then this is amount of years. So T. Looking at this problem, tell the person closest to you, what's the rate? What's the percentage as a decimal? Finn, enlighten me. What is it? As a decimal.
As a decimal, that would be 0.86.
What are you on? Okay, so R is 0.14. What is my starting amount? Ellie. I'm calling you again today.
19,995.
Okay, so that's going to be P. And Bella, how many times does this happen per year? Once. Because it happens each year. One time. And we don't know our value for T yet. Right now we're just going to make the equation. And then we can plug in next. So our equation is going to be A is equal to 19,995. Okay. Are we going to add 0.14 or subtract 0.14, guys? Subtract, because it's depreciating, decreasing in value. We want it to be less than 1. That way the number gets smaller every time. So 1 minus 0.14 is what again, Finn?
0.86.
Yeah, so I can put 0.86 here. And if I'm going to go and write this out just so we see it. So this is how we get it. 1 minus 0.14 over, it happens once per year. Okay. And again, once per year times my number of years. So if you simplify that, we get this. we're going to plug in 3 years for t. .86 to the t. You don't even have to use that fancy equation if you know it's happening yearly. Starting amount times how much it's going down by, common ratio, to the t. So it's the same equation as a times b to the x. So plug in 3 for t. So and this is money. Good. We want to know at what point does it hit this? It's worth 5,000. So we can put this in y1, and if we put this in y2, all of this, and if we graph those two things and find where they intersect, then we'll know when the exponential gets to 5,000 or lower. That'll be more accurate. You could also use your table and see if you can tell precisely, but I'm going to go ahead and use a graph. So we're going to write it as time greater than, well, since we rounded up, it should work. After how long? 9.19 years. I'll say after. And so exponential regression, it tells you what it's going to be. Equation for the model. Equation model for this data, rounding all values to the nearest 10,000th. And then we'll predict the nearest whole number where it's going to be at the 18th hour. Borrowing your paper.
It looks like you just wrote 27.2025 1.1509.
Ooh. Okay, what do we get after 18 years? Someone who used the equation. Suffolk? 321? 41. And then did anybody use the table?
No.
Pierre?
Pierre, put your hand.
What do you got? 341.42. So using the equation, you get 341. You could also use a table, though, and that works just